capacity of a computer program to evaluate its behavior and code and make changes is known as reflection. For example, in C Sharp, reflection allows you to observe and alter data about your program during runtime, which has immense potential that you may not be aware of right now. C Sharp reflection capabilities, sometimes known as reflection, are tremendously powerful and surprisingly simple to use. And on that note, I'm Vaibhav Khandelwal and I welcome you all to our Simplilearn YouTube channel. Today, we'll be going over C Sharp reflection. But first, let me remind you that we have our daily updates on numerous technologies. So if you are a tech geek looking for the latest technological advancements, then try subscribing to our YouTube channel and don't forget to hit that bell icon so you never miss an update from Simplilearn. So now, without any further ado, let's get started with the agenda for today's session. We will begin our session with a discussion on what is metadata, followed by a brief discussion on C# reflection. Then we will have an in-depth discussion on type class. Following that, we will implement some of the methods we have learned during this session with a simple demo. Finally, we will conclude this session with a quick look into the applications of C# reflection. So now, let's get started with the discussion on what a metadata is. First, a metadata is a binary data stored in a memory or a language runtime portable executable file. Data is moved to another file section when you build code from a portable executable file. Before copying the code to another file partition, it is transferred to MSIL, that is Microsoft's intermediate language. Next, the metadata contains all data types and data members specified and referenced in the assembly. The information is loaded from memory when C# code is executed at runtime. Then, the primary goal of C# metadata is to learn about the class, the data members, inheritance, and the data types, among other things. The file's metadata is made up of tables and heap data structure. At last, it is essential for a simple programming paradigm and eliminates the need of ideal, that is interface definition language, files and header files. Next, let's discuss what a C# reflection is. First, reflection is defined in the computer science as the technique through which the computer program may view and adjust its structure and behavior. The system.reflection namespace contains the classes that provides access to running programs metadata. Next, the namespace system.reflection allows you to acquire information about the loaded assemblies and their constituents, such as classes, methods, and value types. There are many classes that are found in system.reflection namespace. Let's discuss. Repeat. There are many classes that are found in system.reflection namespace. Let's discuss some of them. First up, we have assembly. An assembly is a recyclable, updatable, and self-describing component of a common language runtime program, or more commonly known as CLR program, and the assembly class will describe it. The assembly name. It describes the assemblies and its distinguishable name. Next, we have member info. This one retrieves details about a member's properties and provides members metadata. Then we have method info. This one explains the method class and provides its metadata. Next up, we have constructor info. It explains the constructor class and provides its metadata. Next, we have event info. It explains the event info and provides its metadata. Finally, we have property info. This will identify a property's features and makes its metadata available. Now that we have a good grasp on concepts like metadata and reflection, let's have a look at the most commonly used or important class, the type class. Type declarations for class types, interface types, enumeration kinds, array types, and value types, and so on are represented by C# type class. It is found in system namespace. It is derived from system.reflection.member.info class. Type class provides support for various methods. Let's have a look at them. First up, we have getType. This one gives the present type. Then we have a getType with a string as an argument. This gives the type of a given argument. Next up, we have getMembers. This one returns all the public members for that type. Then we have getMembers with an argument as binding flags. This one will get us a list of all the members of the type that match the specified requirement given by binding flags. Then we have getConstructor. This one returns all the public constructors for the type getConstructor. Then we have a getConstructor with an argument as binding flags. This will gets us a list of all the constructors of the type that match the specified requirement. Then we have getFields. This one returns all the public fields for the type. Then we have a getFields with an argument as binding flags. This one gets us a list of all the fields of the type that match the specified requirement. Then we have getMethod. This one returns all the public methods for the type. Next up, we have getMethods with an argument as binding flags. This one gets us a list of all the methods of the type that matches the specified requirements specified by binding flags. Finally, we have getProperties_set. This one returns all the public properties for the type. Then we have a getProperties with a binding flags as its argument. This one gets us a list of all the properties of the type that matches the specified requirements. Now that we are familiar with some of these methods, let's go to our Visual Studio and check them out. Let's start by creating a new project. We will create a console application. Note that we will be using the one which can use a .NET Core, so as well as C#. So we will use this one. Then we will go next. Let's name it as simply reflection demo. Then we can choose the location according to you. I'm using Simply Project. Then I will go click next. Then we can use the target framework. I'm using .NET 5.0. You can use according to your need. You can also use 3.1. Then we will hit create. Now this will take some time to create the project. Here, now we have a typical project. Now, we will right click on the solution. We will go add and select new project. This time, we will be creating a class library. Make sure you are using a C# one, as well as which one that supports .NET Core. Then we will hit next. Now let's name this as simply print database. Then we will hit next. We will again prompted us to choose the framework. We will be using the same one which we used last time. So if you are using a 3.1, then select 3.1. If you are using 6.0, then use 6.0. Then we will hit create. And here we have our first class library. Now let's write up some code for this Simplilearn print database class1.cs. So let's hit enter here. We will start with the private string employee data. Repeat. We will start with private string employee name. We will hit enter. Then we will have a public void simply print. Then in this we will have a console dot write line. Here we will be printing from simply print. We will create another function, a public string simply get name. Let's close this to make space. Then we will return this dot employee name. Then we will make another method which will be public void simply print name. This will have console dot write line. Here we will use dollar symbol. Then we will write employee name passed as. Then we will have curly braces and we will write our variable employee name. Then we will get out of this. Next, let's write another one of the for function. This will be a private method. So private void simply print private. Then here we will use console dot write line and return a message as printing from simply print private. After that, we will have a public employee name arrow employee name. That was our variable. Then we have a public static string. Then we will have a static employee name with an arrow pointing to a message static property employee name. Then we will have semicolon. Now let's save this and go over to our program folder, which is basically our Simplilearn reflection.demo program file. Now let's write a code for this one. Delete this part. But first, let's go back here and build this. We will rebuild solution. We did that because we wanted this path. Simply print database.dll file. We will copy this. We will be needing this for our next code. So now we are here. Let's add some namespaces. So using system dot link. Also we will be using system dot reflection. So now let's get started. We will go to our main block and then we will have var, which we will name this as simply assembly equals to assembly dot load from. Then we will have at the rate and we will copy paste this path we copied yes last time. Semicolon. Then we will hit enter. Then we will have a for each. Then we will have var type in simply assembly dot get types. Then we will print out console dot write line then we will have a dollar symbol, then in bracket we will write as type colon, then we will have type dot name. Then we will have another console line dot write line. Here we will add a simple line to make the transition. Next, we will write a variable simply instance, which will be equals to activator dot create instance type. Basically, this activator will help us in changing the values at runtime. So then we hit enter. Now we will write some for each statements. So we will have first for each, and this one will have var field in type dot get fields. Now we will have some binding flags dot non-public. Then we will do or we have binding flags dot instance. Then we have binding flag dot declared only. Then in this body we will have a console dot write line. We will have a dollar symbol. Then we will write field. Then in curly braces we will have field dot name. Now we will be making the similar types of for each statements again and again. Let's also write a command to set a value to these fields. So let's have command as field dot set value. Then we will have simply instance comma. We can write any name here. Let's write James. Then we'll hit enter. Now let's get out of this for each, and here we will write another one of console dot write line. Then we will have another one of those dividers. Next, we will have another for each. Let's copy paste the earlier one so that we don't have to do that again and again. Let's close this, Control V. Now the next one will be on method. So we will change method here. In type.get methods. Now this one we will also have a binding flag dot public. And for the declared only part, we also have a where command where this m should be not equals to m dot is special name. Then in the body we will have our first data as method. Then we will have method name. As per, let's clear this one up. Now let's have if block method dot get parameters dot length is greater than 0. Then we will invoke method dot invoke simply instance comma new array. Then in curly braces we will give it the name as Peter. Else if method dot return type dot name is not equals to void, then we will have var return value equals to method dot invoke. Then we will have simply instance comma null. Then we will have an else block. In the else block we will have method dot invoke, then we will have simply instance, comma, null. Then we have this console.writeLine 9. Similarly, we will write a code for the property. So let's write a for each with its argument as var type in type dot get properties. Then we will have console dot writeLine. Then we will have dollar symbol and we will print out property curly braces property dot name. In the next line, we will have a var with a variable name as property value equals to property dot get value, and it will take the property value from simply instance. Then we will have another print statement, console dot writeLine. We have dollar symbol. Then we will have property value. Then in the curly braces, we will have property value semicolon. Then outside we will have console dot writeLine. Then we will have divider. Now let's save this and run it. Make sure to save this one as well. Let's run them. Now as you can see, it has first print the type as class 1, which was the name of our class library. Then we have method, then we have field, which was our employee name. Then we have created a method which was simply print, which was printing from simply print. Then we also have another method as simply get name. We have method as simply print name. Then employee name was passed as James. Then we also have simply print private, which was printing from simply print private. Now if you notice, in the binding flags for our methods, I used a non-public and a public. So a non-public is responsible for printing out the private method, and public is responsible for printing out the others. Then we have properties. For properties, we have employee name. Then its value was James because we passed James as the new name. Then we have a static employee. Since it's a static employee name, so when we changed the name to Peter, it didn't get changed. And the property value was printed as static property employee name. Now let's close this and get back to our slides. Finally, let's discuss some of the applications of C# reflection. First, it permits the creation of new types during runtime and executes various actions utilizing those kinds. Then we have attribute information that can be seen during a runtime. Following that, we also have late binding, which two functions and attributes are permitted. At last, it also enables instantiating numerous kinds within an assembly. And this was all for today's session. Hope you guys found it informative and helpful. If you liked this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.